Welcome, everybody, to the June 26th, 2025 edition of the Technical Advisory Council of the Confidential Computing Consortium. We are an open and collaborative group. Everybody's welcome to join in the conversation here, as well as contribute to our open source projects and our other open ecosystem development. We also abide by the antitrust policy of the Linux Foundation, and you can read more about that at linuxfoundation.org/antitrust-policy. Today, we were planning to have the OE update, but Radhika had some travel that was a little too close to the meeting and thought she'd do better to prepare for our next session in a couple weeks. So we have moved that out. So what we'll do instead today is do a quick recap of thoughts people have from the summit, and then we'll get into a topic that Usama posted to the TAC mail list earlier this week. And from there, we'll check in on that glossary, see if we can make a little bit of progress there and still get everybody out earlier than planned. Any other topics people were expecting for the agenda today? Okay, I am going to skip over roll call since we don't have any voting topics. But if this is your first time or even second time and you haven't had a chance to introduce yourself to the group, feel free to pop off of mute and let us know how you like to be addressed and what your interest in confidential computing is.
Hi, my name is Victoria. I'm at InfoSec Global. That's my company, and we do PQC and related things. So things like discovery and crypto agility. And I guess I'm interested in this as a cryptographer, as it seems like a promising area of development in the future. I went to the the summit last week, I guess it was. Geez, time flies. And met a few of you, but yeah, I'm mostly coming just to see what goes on in the consortium and to see how I can take part.
Excellent. Yeah, it was nice to meet you while we were there. Usama?
Yeah, I think it's my probably second meeting, but I hope a lot of you already know me. So anyway, I will introduce. And at the time I joined the Confidential Computing Consortium. TAC meetings used to be closed, so I didn't have a chance at that point in time. But anyway, I'm a researcher here at TU Dresden, and my main focus is on the formal analysis of attestation schemes. Mainly, I'm now currently working on attested TLS. That's also something that I will talk about. And I also lead a couple of projects at the CCC Attestation SIG, where we are trying to standardize the attestation mechanisms for confidential computing.
Great. Glad to have you leading a topic with us today. All right, last time we had the update from Coconut, and we talked about the glossary, and we decided we weren't going to close it. We should probably make some effort to get it cleaned up because that still has some utility. And then we closed up an item that was blocking getting some of the governance patterns out. And we decided what we would do to sync up at the summit, and then I managed to still be late for that little get-together that we had, since one of the sessions ran long. But that's what we did last time. And since that last topic was the summit, it kind of rolls nicely into just having a little bit of open discussion. If people had some takeaways from being together last week in San Francisco, since probably it looks like a lot of the people, maybe half the people on the call or so, weren't able to be there in person. Maybe share some thoughts about something that you learned, maybe something that was a little surprising.
Um, sorry, Dan, could you repeat the question?
I was just saying for the summit. So people who were at the summit, maybe you found something interesting that you'd like to share with people who weren't able to be there in person. So I can maybe kind of stimulate some thinking. Obviously, one of the main topics was AI and what we've come to call confidential AI. There were several presentations on that. I had a session that I delivered along with colleagues from NVIDIA and Canonical on improvements in setting up the bounce buffer. And if you haven't dealt with a bounce buffer before, that's the idea that in order to communicate with a device using memory mapped I/O, we need to open up an extra page along the side of the confidential VM, and that's what you use to communicate with the device. But because that page necessarily, for now, has to be in unprotected memory, we have to set up a key agreement through there using SPDM. So we talked about that and some of the ways that that's easier with some scripts. So there's going to be links that are available in the presentation materials that we had. I think all the presentation materials become available at some point. I don't know what that point is, but there is a lot of good content out there.
I know last year it took like I think a month roughly for them to be online. I guess it's going to be the same timeline this year.
Alec?
Hey, thanks, Dan. And speaking as someone who was unable to attend, I appreciate the summary, and anybody who's willing to help me live vicariously through you, I would much appreciate any sentiment on the topic. Specifically to your point, Dan, was your presentation SGX specific, or did it also include TDX?
It was in fact TDX. So yeah, it was TDX using Ubuntu with an NVIDIA H100 card. But the general pattern there you could use with probably SEV and Red Hat and eventually somebody else's GPU once they get those capabilities of having an SPDM responder in the card.
Got it. Makes perfect sense. So H100 supports TDISP and SPDM, and so that's why you were able to use that as a proof of concept.
It supports SPDM. I don't think it supports TDISP. I think the Blackwell card. Fritz would be more the authority here than me, but
yeah, Blackwell does. H100 doesn't.
Mm-hmm.
Got it.
Very
So you
specific
exchanged.
question.
So you exchange keys without first having exchanged attestation evidence?
So SPDM is what you use to do the attestation exchange as well as the key exchange. And then what TDISP would layer on top of that is once you have that secure channel, then you move the device into like a locked mode and then a secure mode. So it's more of a state machine that happens on top of that.
Cool.
I think that's generally the main difference.
Thank you.
I think there's also some DMA differences, but Yash?
Yeah, so my experience of Summit, this was my second year attending. I was there last year as well. So comparing with last year there was a lot of talk about how AI could be a use case for conventional computing and where a lot of the platform and vendors saw the industry adopting the technology. And my observation this year was that what they promised last year, they actually did deliver. So a lot of at least the big data companies, if I can say it that way, they have started using conventional computing in production. So I know Meta did not have a talk, but their paper was referenced as a use case several times for the WhatsApp private processing. TikTok put forward their talk. Apple and Amazon did not have a talk, but they were present as well because they both have some amount of conventional computing in production. And I think, yeah, model inferencing in a confidential environment, either a VM or a container, is going to be a big use case. And yeah, so I've been in the space for like 2 years now, and my opinion was that we were waiting for a use case to really push adoption, and secure AI or confidential AI seems to be the use case that might accelerate it. So yeah, I'm excited to see where this goes. There were a lot of other, I would say, consulting companies as well. Accenture had a keynote, McKinsey had a keynote. So it's a promising time to be in the space. Yeah.
Yeah, I actually, that's a good summary. I want to second that. So where last year we had a lot of these, what could you do with the technology talks, we now had a lot of look at what we did with the technology talks. So one example Yash didn't mention was also last year Google gave a talk about their ad tech business, what they could do with CC or what they're planning to do with CC, and how kind of that can change their ad tech. And now there was another talk about like how it is now integrated and all of these things of bidding and pricing and whatever is used. So yeah, while Yash said it, it kind of brought the point home indeed. And another thing is then, I guess, that we now kind of reach the second stage, right? Of we don't talk about what could we do, we kind of talk about what did we already do. And that's exactly bringing in these consulting companies, like we had Accenture and McKinsey. But it didn't bring in enterprise customers yet, as far as I could see. Maybe there was some and I didn't see them, but kind of the end customers that would be the consumers of this, they were not present. And maybe this changes next year, right? Maybe this is like something that takes another few years, or this will never happen. But indeed, the AI seems to currently be the big push for this, right? To kind of drive the big demand for confidential or isolated computing. May it be for protecting your model from your customers. But right now, at least at this CC Summit, we didn't see the end users yet. Maybe that will change next year. So it's going to be interesting how this kind of maybe shifts to like the next level. And then we'll have like some conference hall with like people buzzing there in a year. But let's see where we go. So it's a good takeaway, Yash. Just wanted to add to that.
Yeah, I actually noticed some end users not necessarily presenting, but being present. I had a couple people come up to me from an insurance company at lunchtime to say hi. And I was like, okay, I didn't expect a non-tech company to be here. But they were actively involved in bringing the technology up for what they work on. And so I thought that was nice to see end users in an industry that you wouldn't think of as necessarily like a tech player.
Yeah, there were several talks, including one of ours from Anjuna with customers. Anonym, which is now Mozilla, was with Intel, I believe. And there was a session of AI genomics with Google Cloud. No, also with Intel, I don't remember. We had one with Rayfinia. But all in all, I agree with everything that you guys said. It felt to me, maybe in the first day, that there was a shift from confidential computing to AI in a way that sometimes didn't feel too connected. There was a talk on the stage of some guy that there was nothing, from my feeling, connected to the technology that we are trying to promote. The other thing that I felt that second year in a row was that it was more of a friend and family event, meaning we all know each other in one way or another. We meet here, we meet in other places. I'm looking for the time that really there would be more customers. I feel that it's still low, but I agree with what you guys said. That this is it's not a sprint, it's a marathon, and we start seeing people running.
Yeah, I wouldn't doubt that just naturally it's going to be the case that we're going to interact with customers more at other conferences. The customer has to have a very concentrated interest to come to a conference that's really about one very specific technology, which is a good reminder that Outreach sponsors a CCC booth at a variety of conferences exactly with that in mind, that we need to kind of be out of our own echo chamber, and they're always looking for people to help support those booths. So maybe it's probably good to check in with Outreach on what the next conference is they're looking for support at.
Yeah.
Usama?
Yeah, I want to thank the people who have given a summary. So because I was unable to travel because of lack of budget. Anyway, I recorded my talk, and I wonder if there was any discussion on the end user. How do the end user get the guarantee that it is confidential? So I wonder if there was a specific talk that I should check out from the perspective of the end user that you mentioned, that there were a couple of talks. Was there something on how would the end user really get the guarantee that I am the communication is with the confidentiality? Was there something around these lines?
So I can at least say a few words about what I saw in the talks that I remember right now. Most deployments that I heard about, or the talks that I saw, were discussing these deployments as sort of a promise that they are now using this technology, right? So it's partially embedded, for example, into the websites that you're using that says, look, you're running in a TEE, or for example, the Meta WhatsApp AI, right? Stating that now this is like whenever you engage with this, it is running in a TEE. But at least I'm not aware whether there are any kind of third-party tools that allow you to verify these claims. So I'm only aware of these claims being part of the product promise, not them being verifiable outside of that product.
Right.
Maybe I'm wrong, but that's at least the extent of what I've seen, at least in last week's talks.
Sure.
There are some fundamental attestation primitive challenges that prevent that from happening, but there's also just general immaturity, right, in the stack in terms of how it's propagated across the industry.
Right. I think the fundamental limitation is that with the web browser, you can have authentication, you cannot have attestation. So that's part of the problem. So you cannot actually show to the end user that it's actually attested. So you can give it a certificate via web, but I don't see any means how you can actually then give it also a certificate for an evidence for attestation that it was actually attested.
No, that's not the whole picture. Sorry, Yash, your hands up. Go ahead.
No, go ahead.
I was just trying to say that's not the whole picture, right? Because just because the web server I engage with is in a TEE doesn't mean that the whole service that I engage with has a solid security posture and is also utilizing all of the tools it can, right? So what you just said is not still not sufficient. That's not what we care about. Like it's part of it, yeah, but that's not the whole picture, right? So it's not that just by placing the web server in the TEE, you can then trust that the whole AI service is running in a TEE, right? So that's what Nathaniel mentioned, that there are just inherent limitations to some point you have to trust this service you engage with to do it correctly. And I guess that's just depending on what specific service you engage with, just a limitation of how things work, I guess. Very contextual.
I would like to solve some of those problems. So if people are interested in having a conversation,
Yeah, definitely. Yeah.
feel free to reach out.
Sure, I will reach out to you. Thanks.
Yeah, so I can share my experience as well. So from speaking with customers here at Red Hat and also, partners and other vendors who are working on this in this space, what I have observed is that when it comes to confidential computing adoption, right, let's say there is a spectrum of customers, like it's a range, and there are customers on one end of the spectrum that care about verification, that care about attestation, that want to make sure that you have the assurances from the TE. And then on the other end of the spectrum are, for lack of a better word, like check the box customers. Like, I want a confidential environment so I can deploy my application and my data is protected. So what I have observed for the major part is in last week in the talks and also in my conversations is that a majority of the customers fall on this side of the spectrum currently, where they want to deploy confidential computing and are not necessarily too worried about the details. They do inherently trust that the vendors can provide the assurances if asked. There will be a few customers who want this, and they are also important, but most of the conversations we are having lie on this side of the spectrum. This is my observation. Okay, two hands. Okay, go ahead, Ophir.
Yeah, I want to fully connect to what you're saying, working with customers, their end customers, which actually we are working with vendors that add confidential computing to their offering. It is for their commitment for their customers that they protect their customers' data in a way that, for example, they even themselves cannot touch. But the end customers, in many cases, we ask them, how do you present remote attestation to the end customer? The end customer, in many cases, does not understand what it is. B, in many cases, there would be some security people on their customer side that will dive into the architecture, but the end user is not expecting to see anything in a browser or somewhere in the system. It's too high for what they're looking for. There is someone else in the organization that tells them, hey, we decided to work with that system. It is protecting our data, and it's not going to that end level of someone looks at the browser and sees that lock of confidential computing. This is an attested service.
Yeah, right. I would say that basically coming back to the Yash point. So I think the reason why the end users are not caring about, they have not much awareness about what the technology is. And I believe that guarantee does not hold unless you have that kind of attestation. So I feel that this is not a good reason to say that, okay, so the most of the customers are on this side rather than this side. So it's basically lack of awareness of the people of the technology because it's emerging and so on. So yeah, but the main point being that without having that attestation for the user, how can he be sure that it's actually, how is it any different from a normal web browser, that service that you connect to? So I think that's the real distinguishing factor, that you have attestation, you are sure that, okay, so it's doing like it is supposed to do. To Ophir's point, I'm not sure if for instance, I'm an end user and somebody tells me that, yes, this service is actually doing that. So I am trusting that specific entity in order to do this for me. So there is another trust vector that I have in my TCB now to ensure that, okay, the technology works as I expect it to work. He has somehow audited it or whatever he has done. I think there is another factor added to the normal trust that I would have in order to be sure that it's actually doing the thing I expected it to do.
Even with HTTPS today, most people do not understand what it means. Most people do not care what it means. And even those that understand, how will you verify that the software measurements are the ones that you trust? Let's say even for you yourself, you're saying, I'm going to connect to a system through a web interface. I expect that web interface to provide me an attestation quote. How would you, be sure that the software measurements that you have there are the one that you trust.
Right, that's a very good question, and we are working on this in the IETF. There is a working draft on providing the reference values. Some people from ARM are working on this problem, but I do not have much insights to share.
Yeah, I'm with you. We are generating attestation codes. We are verifying attestation codes. That's great. But with a software that updates 100 times a day, those software measurements keeps on changing, and you want your software to be stable, so you expect it to be bugless. Let's say Netflix runs in confidential computing, and you want to be sure on your Netflix client on your TV that it is running a version that you trust, but those versions change thousands of times a day. So think about that problem. It's not only the processors. They already give us everything that we need in order to generate an attestation quote and to verify an attestation quote. Everything is well known, and it's just a.
So you want to bring these to GRC and trustworthy workload identity working groups, because we are not just working on them, but we have architectural guidance around exactly how to do that.
Mhm.
Now, if you want, I can briefly cover it here, or you can come join us for our discussions.
Yeah, as Fritz has already mentioned, like it's very much related to the talk I'm going to give, so it's a good preamble to that, I would say.
Yeah. All right. Well, we'll let Alec get in since he had his hand raised, and then we'll move into that.
I'll just wait and listen to the doc. The thing that triggered me a little bit was when Ophir said, "How do people understand HTTPS?" And I think it's a brand thing, honestly. People, if you even think to click on the little locky thing, all you see is the certificate was provided by name your company's brand, right? And it can be, you know, a well-known brand that advertises on TV, or it can be a public, you know, let's encrypt kind of a thing. And that's the only reason you trust it, is because of that brand. And I don't know if that's what Ophir was alluding to, or if he was alluding to something where people are actually going to dig through the attestation evidence and figure out whether all those numbers mean something to them.
Well, I think we'll put a pin in it there as sort of an open thought for continued discussion, and see where Usama wants to take us now. So hopefully you've read the notes that you sent to the list, and we already had some good dialogue to move this forward from Fritz. And I will turn things over to Usama to set up the problem. And I've got the outreach document and our TAC document that maybe relate to some of these definitions in the wings here to pull in as needed.
Dan, can I add just one quick comment, which is I want to make sure that we can find a way that this doesn't get buried in one working group, because this actually touches across a variety of concerns across a variety of working groups. And since it's a cross-cutting concern, I don't know that we have a good place to have the right audience. So that might just be something for us to reflect about. Thanks.
Fair enough. So we often bring in things from the working groups into this meeting. And so, you know, as topics relate to this, people can definitely request them on the agenda. In fact, that would be a big help for me, is other people offering things that they would like to discuss on the agenda. Otherwise, you know, it's just up to me to figure out what happens to be going on in that particular 2-week cycle. Make use of our time best. All right, Usama, the floor is yours.
Right, thank you. So it says you cannot start screen share.
I will let you share then.
Thank you. Okay, so do you see the slides?
I do.
Okay, perfect. Yeah, thanks for having me. I'm going to basically talk about the tested TLS protocol standardization specifically for confidential computing, as was sent around on the mailing list. And I want to thank all the people who have contributed to this, Arto, Hannes, Thomas, Simon, Ned, Mariam, Thomas, Yaron, Jonat, and Jan Mary, who have been influential in all of the work that I will be presenting. And I would say, I'm not sure how the talks go in tech, but I would prefer if we have any short clarification questions in between, and some long discussion at the end of the talk, like roughly there are, I think, around 12 or so slides, and the rest of them are just extra slides just in case they are required. So I would suggest if there is any clarification required in between, please feel free to interrupt. Otherwise, I will like to go through the slide deck and then we will have some discussion. Okay, so my plan is to give a very quick background on what this attested TLS problem is and what we are trying to do in the standardization body, namely IETF. And I will describe in section 2 a bit of the security considerations that we have found by formal analysis. And then there is the main topic that I want to discuss, like the issue with the TCB and so on. So just to keep, just to have some everybody on the same page, I have this as a reminder that confidential computing does not work without this architecturally defined attestation. And this term comes from Ijlal. And the reason is that basically this is hardware-based rather than software-based. So this term, to distinguish this from other types of attestation and so on. So this term was proposed in the CCC attestation SIG. And so since then, we are using this term. And the idea is related to, and the terminology basically I'm going to use is of IETF, namely RFC 9334, which says that there are 3 participants in attestation: the attester, verifier, and relying party. And they never describe what is the communication between the verifier and the relying party. It's unspecified until now. So what I do is, for now, I have taken both as one, meaning that when I call it verifying relying party, that means both parties are residing at the same place, or otherwise they have a secure channel which is trusted by both parties. Or think of it maybe as that the relying party has an authentic public key of the verifier that it trusts. So that's somehow a way to resolve the tension between the 3 parties and the 2-party protocol that TLS is, that I will come to. So the way it happens is this combined role verifying relying party sends over an attestation challenge. The attester generates an evidence and sends it over back to the verifying relying party, which appraises it. And if required, it will send over its secrets or sensitive data back to the attester in order to perform some computation. And this can be a cloud scenario where it wants to protect against some other users, for instance, the ones which are running on the same machine, and not necessarily from the cloud provider itself. I will come back to this point. Okay, so in order to categorize like a bunch of attested TLS protocols, we have in the attestation SIG come up with these 3 main criteria, like 3 main types: pre-handshake attestation, intra-handshake, and post-handshake. I have in this slide an example of each. Namely, this is the Intel's RATLS protocol, widely used in several solutions. It's open source, and in our previous work as part of the SIG project, we have done its formal analysis as well. And on the second one is the TLS attest protocol, which is one of the internet drafts that is proposed. And this is basically, it has open source implementation, and it has its informal specifications available in the form of an internet draft, but there is no formal specification yet. which is actually a requirement in the TLS working group of the IETF, which has high security standards, and they do not accept any non-trivial changes to the TLS protocol without having a formal analysis. And that's where we did all the work in the SIG in order to turn these crosses into ticks. That's what also my talk is about, in order to fix that thing. And finally, from the post-handshake side, there are all the clauses. That's a closed source implementation, and it has no specifications available, not even informal. Yeah, so it was definitely not possible to standardize it. Right, so that's basically starting point for the security considerations. And what we found for the internet draft is there is a section 6.1 of this internet draft that I mentioned, like the intra-handshake option. And what it says is basically an option of remote attestation only, which the editors couldn't really describe what the use case is. Anyway, because of the requirements, we did the formal analysis of this. And what it says is basically, what could happen, for instance, is I, as a TLS client, I want to connect to a TLS server, which is running in the trusted execution environment. Let's say I want to connect to cloud.example.com. And from TLS perspective, it acts, from the RATS perspective, it acts as the verifying relying party. And on this side, this is the attester from the RATS perspective. So it gets a nice evidence based on this TLS protocol extension that is proposed, which is namely in a very short term, like it has, of course, like all the fields, but in very abstract form, we can think of it as the measurements represented by M, and the public key corresponding to the private key that it has ephemerally generated. And with this evidence, the client can get a guarantee that it has the expected measurements. Let's say out of magic, somehow he knows that what is the required measurements, or the reference values, as is the terminology, the reference values corresponding to this measurement, he has somehow obtained it. And by that, it can check and verify that it's correct. So the question which comes is an average cloud customer happy with this, having this evidence, rather than what is the identity of that specific server that it is connecting to, which is very typical in a TLS connection? And I believe the answer is no. And the reason for that is that if I don't have that identity, I could be redirected to a completely different machine, which has likely and hopefully the same software that I want to run and the same measurements, but it could be in a country which is not what I would expect my data to be, number one. And number two, it could have been secretly broken and not yet revoked. And that's where the problem lies, that it could be, and other than breaking the machine, for instance, there are a number of threat vectors which are explicitly out of scope of confidential computing. So one could eventually break these things. And the problem here is that I could divert it to that specific data center where I have broken that machine, and then utilize these side channel attacks to launch an attack on the client who believes that it has the right measurements, but doesn't know the identity of the host that it is connecting to. And the host name is also not measured, so the measurement do not contain that. That's why this possibility exists. This is a summary of that, all that what I have said, and we call it identity crisis, namely using this proposed protocol, namely the TLS protocol, the security breaks even if there is one compromised machine. Compromise here means that the attestation key actually has been compromised for that specific machine. And it's not in that specific data center. That's the main important point that I want to highlight. It's any compromised machine anywhere in the world. That's the key point, that because otherwise it's trivial. If I am connecting, for instance, to this machine, its attestation key is leaked. Of course, trivially, everything breaks, the security breaks and so on. But what we are highlighting here is a very subtle thing, which is that any machine of the world, if that is compromised, my security breaks, which is, I believe, a much stronger security condition that is required in order to hold for all machines in the world to be secure. For my security to hold, that's a much worse thing than having one machine being compromised. And the assumption for that is that that specific key, for instance, for the provisioning certification key, certificate for attestation key, has not yet been revoked. Right, so that's that leads me to the discussion that I want to have specifically for this proof to hold. I have to have a trust in the CSP, and that's where in the SIG we collected some let's say some points on where CSP is already trusted or we cannot eliminate that trust. One of those is the availability, namely I want the CSP to keep the machine up, keep the lights on, and keep the bits moving. Otherwise, nothing can happen. I cannot have any confidentiality at all if nothing is going on. Secondly, about the machine identifier, referring to the identity that is given to a specific machine. So this is something that is done by the CSP. The domain name system is in control of CSP. It can assign identity. So, and I have to trust the CSP in order to give me the identity. So it cannot be done without trust in the CSP. And there is a host affinity requirement of data sovereignty regulations in several countries, which says that I need to know what machine I am talking to. And that's such a proposal or such a protocol proposal actually would violate such requirements that it could go to a host which is not the one that I desired. Also, a related note on this is the location point, that I cannot be sure of the location by any means other than the CSP being the only source of truth for the location of where that specific machine is located. The point being that a CSP could tell me it's in the EU, but it could be, for instance, in the US, and I have to just trust them for that. So there is no other source by which I can actually assess that or check that whether they are really telling me the truth or not. And similar to the host affinity, there are location affinity requirements, and they come from the data residency regulations, which many countries also have, and which means that I want the EU data, for instance, even if it is encrypted, to remain in the EU, and for instance, within a specific country and so on. So these location affinity requirements cannot be fulfilled without having the trust in the CSP. So in this slide, I mentioned the general cases, which to the best of my knowledge apply to all cases without any exception. I mean, this is quite generic. Whatever T you have, doesn't matter. Whatever cloud provider you have, it doesn't matter. They hold in all generality. And on the next slide.
Usama, just one second there.
Sure.
So you said you want to have detailed discussions later, but because I pretty much disagree with every single thing being generic, or each of these being generic, I think we could spend the rest of the 2 hours on just this slide. So just to make you aware of, later on, maybe you should like specifically clearly state which one you want to discuss or what you want to discuss. Because alone on this slide, I don't know, we could pick it apart for an hour or so and discuss why I disagree with it.
So, okay, so I think I have only a couple of slides left, so I can, if it's fine for you, we can go ahead and finish it, or otherwise.
Yeah, I was just trying to follow the point of like just awareness now, just for you to be aware of kind of the reverse direction that if you don't focus the discussion later on, it will go back to this, at least in my books.
Okay, right. So So this is more technical than regulatory perspective, and that's for most cases, not for all cases, as I have a table here down, which is saying that the CSP is trusted for number one, any part of the boot software that is not open source and not independently reproducible. For instance, AWS, to the best of my knowledge, is the only cloud provider which satisfies this. Others, even if they have some parts open source, they do not have it fully open source, or otherwise they do not provide you the means to actually reproduce independently. And closed source is bad because it may contain backdoors, and you still need to trust the CSP, what they have put it into your VM, for instance. And the second point here is mentioning that I cannot ensure that what configurations the VTPM inside the VM has been configured with. For example, I cannot be sure whether the non-migratability of the keys option is enabled or not. And second point is related to early boot measurements stored in the virtual TPM, specifically AWS and Google do not provide a VTPM which is protected by confidential computing means, meaning that they could essentially put in any values, or they could feed in any specific values of the measurements to the VTPM, and they could show you essentially what you want. And that's not what confidential computing should be. And the third one is, even for remote attestation, the CSP has a big role in doing the remote attestation, which is the one which gives you the guarantee that you are actually protected. And for instance, like Microsoft does not allow you to fetch the raw evidence directly. And I think this is my last slide, which is giving an example of what is currently done. And for instance, how Microsoft does it is, there is a two-step process of measurement, which is namely that the T is basically going to measure the VM firmware and the UEFI, and then the VTPM is actually, it's not measurement-wide VTPM, it's some other trusted component which actually does the measurement and feeds it into the VTPM for doing that measurement. And anyway, the idea is that it's a two-step process, and if that VTPM is not protected or its configurations are not known to me at the, or I cannot independently reproduce what is being configured here, what this measurement represents, I cannot be sure what exactly has been done to this and how this VTPM has been configured. And more technically speaking, like there are 2 points that were proposed in the SIG attestation SIG. I mean, for this, namely, who owns the seed for the endorsement key for VTPM and who signs the endorsement key for VTPM, and they are both going to be trusted. And for Microsoft, the one which is providing this VTPM inside confidential computing, it's still unclear whether such requirements have been fulfilled or are fulfilled, or what is the guarantee to us that they are actually fulfilled. So yeah, so what I would I want to discuss here is that I would like this statements related to the CSP being out of the TCB to be removed from the white paper. Even though I understand that it's saying aims to remove that, my point is simply that it's an unrealistic aim. And with all the points that I have mentioned, of course, we can have the discussion over that. I would say it's not realistic to actually achieve to have the CSP being out of the TCB, and it needs a completely different threat model than the one that is currently around. And yeah, second thing I would like is that to be explicitly mentioned that the location is out of scope of confidential computing, because we cannot provide any guarantee on the location without having a trust in the CSP. And yeah, so we would like this to be resolved until the next IETF meeting, which is where we have a working group BOF, working group forming BOF for this standardization. And yeah, I would, yeah, these are the people who have contributed to all the work that I have mentioned. And with that, I would like to have some discussions now. Fritz.
You heard from me already, I think also in the stations several times. So I will yield the floor to others if they have comments, because I guess that will be productive. But can you go back to the last slides, to the next steps? Yeah, just the next steps. Because so I want to address this first one purely semantical at this point. I think there's more issues that I see once we go to the details that I disagree with, but just here purely semantical, I do not think we should remove a statement about the general goal of the technology, aka where do we want to go, just with evidence that states where we are now. And that is because we can always try to achieve something and try to go for something and state we want to go there, but then just saying that we don't have it right now shouldn't make us remove that goal, right? I think you, speaking of like you academic, as an academic, are free to write papers about, look, this technology or Azure or SGX or Hopper or whatever currently does not achieve this goal, right? Or CSPs don't achieve this goal or whatever. And then this can be debated and can be peer reviewed and whatever. But the white paper is not an academic peer-reviewed piece, right? It's more a statement piece of the CCC, what we see this technology and where do we want this technology to be in like now, X years, 5 years, 10 years. And so removing that statement from there, I don't see the point. So that's more a semantic issue. And maybe then I'll yield for others, because I think there will be other opinions here that are worthwhile.
Right. So before going to others, I would like to address this point. So what I want to say here is that, in my opinion, even if we achieve that or achievement of that specific thing technically would not mean anything. I mean, if I don't trust Google, why would I send my data over to Google to do the analysis? And I completely understand your perspective. You are absolutely fine in saying that as an academic, I can write papers, but that's what I wanted to hint over at this point, or maybe by this slide, saying that it's not for academic papers. Of course, removing that point will actually kill my paper if I were to go for this. I could write nicer papers by saying that, hey, there is a statement in this white paper and it's completely broken and it's wrong and so on. But what we want to do is to solve this problem rather than solving the paper's problem. So we want to proceed with the standardization. Mainly, that's the goal of coming here, that we need to get it resolved from standardization perspective to provide TLS working group a proof that it works under the threat model that is accepted by the industry. And it's very common that people in every talk would have it in the industry that CSP is out of the TCP. So it's something that we need to critically think on. Rather than saying that it's just an aim that we are looking for. I think even if we achieve that technically, that's different from having it, whether it is true in reality or not. So this problem, for instance, would not be resolved even if I have means to do that completely out of the TCP. So how would I, for instance, stop it from going to any other machine in the world which can be compromised and not yet revoked? So I think that's an important perspective that should be taken care of.
So folks,
Can
several people have their hands up, but I have to drop in 2 minutes for a meeting. So I just request your patience with me, permission to speak up, and then I will probably have to draw. So in the trustworthy workload identity group, we're looking into this. And we basically say there is this maxim: I trust some people with my money and some with my children. They're not the same people. There are claims around the workload identity and there are claims around platform identity. They will come from different places. And as a result, this is not a question of who is in TCB and who is not out of TCB. That's complete misdirection. What happens is I will trust that this is my payroll application, and I will trust that to Intel or whoever manufactures my CPU. And I will trust that the physical server is located in Germany. And I will trust my CSP, and it's a contractual obligation, and it's a question of enforcing a contract and having a risk acceptance of the fact that some party might break a contract. So I think the conclusions in this paper are frankly bogus.
I would, it's not a paper, so to say. It's just a presentation, what I'm delivering here. But I would say that please limit your claims to more technical justifications before saying it's bogus. How would you achieve this with the help of this protocol, for instance?
So bring this to trustworthy workload identity. Happy to discuss it there, but unfortunately, I have to drop.
So you cannot
No,
claim.
I can, but not in the remaining 10 seconds I have before my next meeting. So TWI meets on Tuesday, 6 a.m. Come bring it there.
You should have the time and patience to listen to others before claiming that this work is bogus, right? So anyway, we will. I don't have time. I have a clash with the meetings that you have, but you feel free to come to the SIG meetings. We had already so many discussions and a majority agreement over there. So you cannot just claim it to work to be bogus, right? So you have to come up with some scientific justifications in order to say that it is.
All right, I think we lost him. So let's move on to I think Ophir looks next in the queue.
Yeah, one of the first statements that you said, and if you don't want to discuss that today because it's not what you aimed for, that's okay. You mentioned that if you take the same workload and run it in AT in another environment you put it like a random dictatorship, it's already considered to be not secure anymore. Can you explain why is that the case? If I know that I trust through the measurements a specific all of the levels of the attestation quote, and if someone else is running the same software, hardware on all of those levels, why is it not secure anymore?
Right. So I think this is the core point that that I want to make. So I would be happy to discuss that. Of course, technically, I'm not saying that it's bogus. So I'm happy to discuss that technically. So my point here is that basically you are right that I could be diverted to any machine and that could be protected by the TEE. So far, so good. That's fine. So you get the measurements, you trust those and so on. But the point here is that you have a specific threat model for the TEs to work, right? And what if that specific entity, which is random dictatorship here, so that specific entity, what if that has actually broken that specific model? And one of the let's say the threat vectors which are out of scope of confidential computing, what if that has exploited that and broken that specific machine? You still get that evidence. Yeah.
Are you talking about side channels that they could leverage?
So it could be any attack. Side channels is one of those. It could be any of the threat vectors that is out of scope. By that means, if they have exploited this and they have got the keys out of that, and there are attacks like foreshadow and so on, which have practically shown this to be correct. So that's what. So I mean, just diverting is not the problem. The problem next stage is that that entity could have actually broken the threat model of the TE in order to get the keys, and you would not diagnose that. You would still get the same measurements with the key that you trust and so on, so everything would look fine.
Okay.
Does that clarify your question?
I think that it might go to what Fritz was saying. There is the theoretic aim/claim that you can run it anywhere, and as long as you know of not any known side channel attacks and things like that, you can run it anywhere. No one can access any secret. It's like, that I can have anyone run my workload as long as it is running what I trust. It could be that they just pay for my CPU time.
Sure. So, but the point I want to emphasize here is that assumption should not be for, let's say, the service provider that you want to talk to. It should be for any machine in the world. So that's what I want to emphasize here.
I agree.
The protocol says the protocol requires us to have all machines in the world to be secure before trusting that specific machine, which I wanted to trust. So it's a full-blown like thing that we need or an assumption that we need in the threat model for this to work. Do you agree with this?
Not sure, but maybe it's I'm not familiar enough with what you're talking about, so we can continue.
Okay.
We haven't often heard from Ijlal in this call, so I'll let her bump the queue here.
Thank you, Dan. Osama, thank you for the presentation. I have to say, I do find myself always having a hard time following this particular conversation, and it comes up often. For me, it boils down to people having different assumptions about the threat model, about who the end user is, and the fact that sometimes, so what I'm hearing from you, Osama, is you always assume the final end user will be somebody that completely distrusts the cloud provider. They distrust the entire software stack within the CVM. And that's one particular use case in which your definition of confidential computing becomes valid. You need to take the CSP out of the trust boundary, etc., etc. But I feel sometimes we are confusing the outcome of the technology with the technology itself. Intel TDX, AMD CVSNP, they just give us new primitives for memory management and access control, which deprivileges the system software. And we can do with it whatever we want to do with it. If I am the CSP and I am the end user, like I am the consumer, the end user consumer of the technology, then potentially I don't need to remove myself completely outside of the trust boundary. It's enough for me that I just remove, I don't know, zero-day vulnerabilities that are coming from the hypervisor, and that's good enough. I'm just hosting my internal Microsoft workloads on CVMs on Microsoft Azure. So what I'm trying to say here is the threat model for confidential computing sometimes become very extreme, like extreme as being very secure. It has to be this mighty CVM that completely is isolated from everything that the CSP or the infrastructure provider gives us. And that's one way, that's one outcome, but it's just one possible outcome of the technology. It is not the only one. And the second thing, I don't know why we always revert to talking about the public cloud providers. The technology is relevant to any other type of deployment. It's relevant to the data center, to the private cloud, where the data owner can collapse with the workload owner, with the platform owner. So I potentially would like us to not paint the technology in white and black. And I agree with you that the end user should not come with the conclusion that the only outcome of the technology ever is to remove trust, the CSP to move out of the trust boundary. That's one possible one. We can be more nuanced, but we also cannot discredit the merits of using CVMs for use cases in which the risk assessment says that it is enough. It is enough for me to trust the public cloud provider with the location information. I might also be enough with him even being within my CVM software stack. I just want to be protected against whatever, the hypervisor. So I just want to keep in mind that different people have different goals, and I don't want the consortium to be in a position where it decides on what those goals are for enterprises. Does it make sense?
Yeah, so I think I'm following what you are saying. The cloud provider being the cloud example being the major one that we often see. So that's why, and I believe that's also the focus in most of the discussions which are for confidential computing. So yeah, so I think that's one of the, at least one of the major use cases that we have. So other, of course, use cases exist. I'm not saying that they do not exist, But I would like to point out to the internet draft again, which is my main focus. So the internet draft actually specifically, if you see section 9.1, I believe, is of this internet draft, which talks about specifically, it mentions cloud confidential computing rather than saying confidential computing in general. So that's why the focus of the verification was explicitly on that specific case for cloud computing.
Well,
So that's
then
what
just
I'm
one
not.
closing thought. Just one closing thought. If there is a customer who refuses today to move to a public cloud because of security concerns, and the risk assessment says that they should not because of this and that, then maybe for them the threat model of completely removing the CSP is relevant. What if there is an existing customer who is fine with running on Azure, and now they have a new primitive that allows them to better protect their workloads? So for them, potentially, this is still a very useful primitive to deploy their workload on. It's defense in depth. It takes out a lot of attackers, potentially, a lot of people who might have touched their workload otherwise without CVMs. So even for those on cloud deployments, it's still relevant to have a weaker notion of protection with CVMs. But I get your point. In the other case, it's very difficult to make the guarantee.
I completely agree with you. That's the point probably I already made at this slide, saying that the guarantees of protection against users and against the cloud provider are completely different threat models. And for users, I completely agree. So this is a useful technology for protection against other users and not against the cloud providers. That's what, just for clarification, that's what I'm trying to say. So what I'm trying to say is I have nothing against protection against other users running on the same machine. I do have concerns against the protection from the cloud users or from the cloud provider itself.
Okay, just a time check here. We're running up on the end of our time for this one. I'll let Nathaniel in and see where we go from there.
Yeah, no pressure on that one, Dan. Thanks. Yeah, I wanted to comment about something I've said in the past, which is that we very often use the definite article with terms like TCB, with terms like end user, and really what we have is a directed acyclic graph of assertions of properties which have to be resolved over the exposure surface of a particular use case as present by multiple different users. That means that while I think the presentation offers a lot of really good thoughts, one of its critical flaws is that it equivocates on the question of the TCB, which is not defined here or in other documents, which is, again, something I've mentioned in the past. What TCB means is highly context specific and highly use case specific. And I think that's it. I'll stop ranting because I know we're out of time.
So
basically,
appreciate it. Basically, to summarize, what you are saying is that the TCP is not defined in my paper, my presentation, or the white paper. Just to be clear.
I don't think I've ever seen it defined in any of the documents I've read. Okay. I may have missed one, but you're doing things like including DNS in TCB, which I think a ton of other use cases would not include in the TCB definition.
Okay.
Right. So if you're talking about tested TLS, and the question is which host do you get routed to, and can you get routed to a host that is, one that has a potential unknown compromise? This is done by exploiting DNS, and I don't know that DNS has ever been explicitly considered in any definition of the TCB, but that's because I don't think there's really any definition of the TCB. I'm not picking on you, Mohammed, if that makes sense. So, I think the whole space is woefully undefined.
at least you agree that in the cloud case, it's the cloud provider who is doing the rerouting, who is managing the DNS. At least you agree to this, right?
No, I mean it could be a nefarious dictatorship, as you've said, right? That's preempting the cloud routing. So there are multiple levels of places where you could attack DNS, for example.
Right, but it is some entity which is other than the one you trust. Like it could be any network or it could be the cloud provider, right? That's the point I'm trying to make. I'm trying to say that it's an untrusted entity in any case.
Yeah, I'm more concerned about I think it was the previous slide where you talked about the trusted computing base. I don't remember which slide it was on now. We've had too many discussions. So yeah, this one here, right at the top, right? Can the CSP really get out of TCP, right? As I have seen the TCP commonly used, I have never seen any of these three items included in the common use definition. But that doesn't mean that they aren't, because I don't think the definition has ever really been defined.
Okay.
Yeah, I think that's a fair observation. And one that I think
just for an incentive to add, academically, there are definitions. So I can, like, if you're interested, just ping on Slack. I can find some academic papers for that if you want.
Well, I don't. Just because there are some academic papers that define the TCP, that doesn't mean that that term is accepted in that use case, right? There's no body that regulates that terminology.
Yeah, fair point.
So
sure.
for our purposes, would we want to add a more formal definition of TCP to the TAC white paper?
Well, I think the argument is rather the scope of the TCP is not defined, right? I think TCP is commonly just used as what is trusted. And then the scope depends on what you do, right?
TCP, I think, often has a variety of definitions. It can include definitions like the components that I get from other parties in order to in order to build an application for a specific use case, right? And that could include software and hardware. I think we rather use this terminology rather naively. And I think that there's probably a lot of people who have reflected on that in a variety of spaces, but I think that it's also used extremely widely in the industry in a variety of use cases, and none of the definitions are probably coterminous.
I think there is a very simple definition of TCP, which I'm thinking about, at least from my perspective here. So of course, everything, if you talk about confidential computing, I can bring up a case that, okay, so this is use case dependent, but there are some basic definitions from a basic perspective. TCP as used here would mean the minimum set of components for which if the security of those components breaks, then the whole system breaks. So the minimum set of components which I still need to trust in order for my rest of the system to work. So that will be.
Well, see, there again, you use the definite article, the whole system, right? What you actually have is a directed acyclic graph of entities across multiple systems for which some subset is used for a particular use case. So there is not the system, right? Except in the sense that there is a global system, but the global system is a significantly wider composition than what is actually used for a particular use case. So I think what you mean by the system in that case is when I have identified a use case, I sub-select the paths of the directed acyclic graph that are relevant to my use case. And for the components which I do not provide, that is the TCP.
Right. So in this case, simply it is this system that I'm talking about. This two-entity system with the network in between, which is untrusted. That's simply it. This is the attester from RAT's perspective. This is the server from TLS perspective, and that's it. We have a protocol, which is two-party protocol, and that's pretty much it. So I don't need to consider any other components that I mean, the thing I'm showing here is irrelevant of if this server was also connecting to a FPGA or was connecting to, let's say, something else. So over some connection and so on. So the problem
Right, but this is just for a simple binary attested TLS use case, right? There are other use cases that are not this use case, which select a different set of nodes in the directed acyclic graph of security assertions.
I would be very interested in knowing such kind of use cases, because typically when you design a protocol, for instance, the one in the context which I'm talking about, it should be applicable to as wider use cases as possible. For instance, TLS was not designed for a specific use case. It was designed for wider use cases, IoT and server side and all this. So I think the protocol should take care of wider use cases, and this is one of those use cases. But yeah,
Right,
so I'd be very interested in knowing these kind of use cases, maybe on the mailing list or so on. But I would like to.
Let me give you one example, right? There's another kind of use case, which is simply, this is the most simple one, and it is, I think, the one that most people quickly reason about because of its narrow scope, which is I am a workload owner, and I want to make sure that my workload is running in confidential computing, right? That's attestation can serve that workload, and that is a different use case than this, although they are related workloads, which is why I get to that point about the directed acyclic graph, right? These are all related workloads that all have there's a universal set of all security claims for which those two use cases select a subset of nodes of that directed acyclic graph to achieve the security properties which are required for that use case.
Right, but in my mind, from a protocol perspective, that's indifferent from having this use case separated from the use case that you are mentioning. I will quickly tell you the reason. The reason is that the protocol does not care about anything other than the measurements that are given to it. The sign happens on this public part and the evidence. It never takes care of anything else. So whatever you are saying will still remain valid for this use case and the use case that you have mentioned. So essentially, for your system,
in the attesting your own workload case, DNS is not part of the TCB.
So where is that workload running, for which you are the workload owner? Where is that running? Isn't it remote?
It's running in my cloud, which I can probably check via a variety of different ways.
Okay, so you have a private cloud use case. So yeah.
Or it could be on premises, right? There's all sorts of embodiments of this, which goes to my core point, which is that.
Yeah, that I agree with you. So I think I already answered when Ijlal or someone was asking. So this internet draft is explicitly mentioning in the use cases confidential cloud computing. So that's probably an answer to your question. And we have verified under these assumptions rather than any other use case specifically.
Right, and my point is that there's two trusted computing bases, right, for these two different use cases. And that trusted computing base for each use case is the composition of the nodes of the directed acyclic graph of trust assertions, which are selected for the security properties desired for a particular use case outcome. We can move this offline. I know it's a longer conversation.
Okay, I think, yeah, that would be better on the list, because as I said, it's clear that it has explicitly mentioned confidential cloud computing. So I haven't analyzed any other use cases. So this is very focused on cloud computing.
Yep. So let's have a conversation offline.
Sure, thanks.
Okay, Alec, you have maybe a very short bit of time here if you like.
Yeah, let me first thank Mohammed for stimulating a very charged conversation here. I appreciate you bringing some sacred cows out on stage so that we can inspect them a little bit more closely. If you go back to your graph there with the random dictator, because I love that one. And one of the early conversations that we had in confidential computing was that our North Star goal would be to have the Department of Defense of a country be willing to run their workloads on infrastructure that's hosted by a country that was at war with them or in conflict with them. And that's kind of like a North Star goal. We can all imagine that that's going to be impossible to achieve, but it's a cool aspirational goal. That's kind of what you're alluding to here in this. Is my workload safe, even with confidential computing, if it's running on infrastructure hosted in a country that's run by a random dictator? What I'd like to, and the real question is are we safe from side channel attacks? And I think the Confidential Computing Consortium has already said, hey, if you've got persistent access to the physical machine, then that's out of scope. And so if a random dictator has persistent access to your physical machine, confidential computing doesn't want to get into the debate as to whether or not your data can be exploited. So we kind of depend on the perimeter security that's provided by cloud service providers that are in less than random dictatorships or even democracies or other forms of government that we put more faith in for reasons that I don't want to delve into right now. So I think this graph is a little bit outside of the scope of confidential computing because it doesn't take physical perimeter security into account. The other thing I think is missing from this graph is that line that goes from the TLS client to cloud.example.com. You don't really have a perimeter of what cloud.example.com is. So if that diversion based on the DNS is within the perimeter of cloud.example.com, then cloud.example.com would be complicit in that DNS attack. And so there would be a little bit of collusion there, right? Am I understanding that correctly?
Right, exactly. I have it in the extra slides. So the case that you are exactly mentioning, that if it is within the CSP, for instance, cloud.example.com, so it could be rerouted to a machine which is then compromised, and you can have a similar attack. That you are exactly right. So this still applies.
So there you go. So right there we have cloud.example.com complicit with the random dictator's desires to redirect IP traffic. So that's important to call out, right? It brings in the need to bring more folks in on the attack. Or obviously if the diversion were outside of cloud.example.com, then the whole internet DNS infrastructure would be complicit with this random dictator. So I just think it's kind of important to call that out, especially when you're dealing with, a large audience that suddenly becomes alarmed by this seeming threat.
Yeah, I was told that this is too complicated for the TAC, apparently. So that's why I put it in the extra slides, but I completely agree with you. So we make a clear distinction between diversion attack outside the data center and within the data center. And coming back to your point, I think about the protocol. So everything lies on the protocol that we are verifying. So if the protocol does not take care of the identity of cloud.example.com, that's the point I want to make, that whole of this protocol, never in this case, you will see the long-term key being used for cloud.example.com. And that's the whole point, that it can be rerouted to anywhere in the world. That's the point of. So you do not need any specific, let's say, DNS or something. So it could be by Dolevio adversary. So you could be rerouted. You essentially, what you check is just the measurements. That's it. You never have any identity in the protocol that's being proposed for standardization.
I think you're landing a very solid point here on what exactly is guaranteed and what is not guaranteed. So that I think this is a great discussion. Thank you for that. I just wanted to raise those 2 points. And again, thanks for a cool presentation and for stimulating a great conversation.
Thank you.
Yep, and I think we will have to wind it up there. I will apologize on behalf of Mark, since he was in a hurry. I don't think he would have normally used a discourteous term, and that's not normally how we conduct ourselves here. So I appreciate everybody else keeping things very courteous, and it's been an interesting conversation.
Yeah, thank you very much from my side. Thanks a lot.
All right. The other agenda topics that we had for today, we're taking a look at the open PRs, and I think we actually managed to resolve some of the minutes that are out there. So I don't think it's worth us taking collective time to look at those right now. The other thing is the glossary. I think rather than looking at any specific terms in the glossary, I think where we left things off was recognition from maybe Alec that the initial reason for that with the interaction with
The Cloud Security Alliance. You're exactly right, Dan.
Thank you.
And the meeting that we were scheduled to have last week was canceled because of CC Summit, so we weren't able to close that topic. I'll keep it open for another week.
Okay, well, we'll come back to that then at our next session and see where we want to take the glossary at that point then.
Cool.
All right, well, I think let's call it a day then and let everybody get back into whatever else you've got to take care of yet today.
Thanks,
All right,
everyone.
Ron.
Thanks,
Bye.
Mohammed.
Thanks,
Thank
everyone.
you.
Bye.
Bye-bye.
Thank you, Mohammed.
Yeah, thanks, Mohammed. That was great.